Students, we were discussing the numericals from your section waves, and one sum we were doing. Okay, and part A of this sum, they are having there are three parts of this particular question. Part A we have solved. Okay, this is the answer for part A. Okay, so till this we have solved. Now we will move to part B and C respectively. Okay, so just repeating the numerical in short. Okay, so this equation is given for the y. Okay, and the datas are given, that is the value of v is given, the velocity. Okay, and the next thing that I'm writing here, students, that value of t is also given, t equals to 0.04 second. Okay, and yes, and in question number B, another data we are getting, that the equation of the oscillation of a point at a distance of 150 meter is given. Alright, so we're getting this data also. That means in a short you are getting the value of x also. Okay, in part B question, not in all the parts you have to apply. Okay, now let's move on to part B. Okay, so what is the question given in part B? The question in part B is, write the equation of oscillation at a point at a distance of 150 meter from the source. So what is this 150? How we can write? In part B, x equals to 150, isn't it? Meter. Okay. So any other data that we are getting? No, we cannot write any other data. Okay. So let's frame the equation. That is, the equation of oscillation of the point is y equals to 15 into 10 to the power minus 2 sine. See, this value is already given in the question, in the equation of y, in the equation of the wave motion, that is your displacement equation. So I'm writing that again within bracket 100 pi t minus pi into x. I'm supposed to write x here, but I will not write x. I will straight away put the value of x, that is 150. That is pi into 150 by 3. See this, follow this previous equation number A. What we had? Amplitude A part, that is 15 into 10 to the power minus 2 sine omega t. Same I'm writing here in part B also. Just, and in the next term of equation A we had pi x by 3, so pi and 3 will be same, and for the x I'm just putting the value of x, that is 150, that is given in question number part B. Clear? So yes, more or less my question number B is done. So let us just reduce it mathematically. What we can write: 15 into 10 to the power minus 2 sine yes, I can write this. Just I have cancelled 3 and 150. So your part B answer will be 15 into 10 to the power minus 2 sine 100 pi t minus 50 pi, and please don't forget to write the unit, that is meter. Clear? Now what is the next question given in part C? That write the equation of the oscillation of the points of the wave at a moment t equals to 0.04 seconds. See the equation, the value of t I have written on top here. So let's write the equation of part C. So your equation of part C will be y equals to 15 into 10 to the power minus 2 sine within bracket 100 pi. Here I am supposed to write t, but I will not write t here. since the value of t is given as t equals to 0.04 second. Okay, so I'm writing the value of t here, that is into 0.04, okay, minus 50 pi. Okay, so for this 50, yes, just a minute, students. Students, for this particular part, that means for part C, we should follow equation A, because equation A was the original equation for the sum throughout. What we were doing in the part B question, we have got one data for this x. That's why I've put it. That's why I've placed the value of x here in the equation number A. But for finding out the equation of part C, students, we'll follow equation A only, isn't it? We should not follow the equation in B, isn't it? Because equation A is our main equation for this sum. So see, I have just done it accordingly. So everything is same. Just for in place of t, I have put this value, that is the value of t is that is given in the question, 0.04 minus pi by 3 into x, because no other values of x is given in the question, isn't it? Just for part C, I have got the value of t. Okay, so let's write it. Just let's reduce it and write it. So 15 into 10 to the minus 2 sine. This will reduce to 4 pi minus pi x by 3. Okay, just following equation A only for part C also. Okay, yes, and this will be in terms of meter. Okay, so in a short, I'm just discussing this particular numerical in a very short way. First of all, the data is what you are getting, the value of y, the value of v, and the value of t. The values of v and t are not given in the that means before the question starting. For each and every part, these values are given. Okay, that means the value of v is given for part A. Okay, for part A question, and for part B, this value of x is given, that is x equals to 150 meter. And for part C, you are getting this values of time period, that is t. All right, so these are the data you are getting. Yes, from these data, just you have to calculate this value of omega from the main equation and the t and other parameters.